Quadratic functions are functions that exist in many places in our world. They're also commonly referred to as parabolas. They belong to a broader group known as polynomial functions, so this is the first polynomial we're going to look at. Previously, we had a conversation about linear equations and their notable feature that the rate of change, or the slope, is constant for any line. The blue shaded box is calculating the slope between 2 points on this line. And you can see that as I manipulate the points, the number in that blue shaded box does not change. Lines have constant slopes. Next, I've put in a quadratic function. And once again, the blue shaded box towards the bottom of the screen is reporting the slope between 2 points on this graph. When I move the 2 points and calculate the slope between them, I get different values everywhere on the curve. So the rate of change, or the slope, is changing. In other words, quadratic functions do not have a constant rate of change. In fact, that's what gives the quadratic its curved shape. The basic features of a quadratic function are shown on this slide. First item of importance is the x-intercepts, the points where the parabola crosses the x-axis. Note that these can also be called zeros or roots of the quadratic equation. We also have the y-intercept, which is the point where the parabola crosses the y-axis. The point at the bottom of this parabola, right in the middle, is known as the vertex. And the vertex will always fall on the axis of symmetry of the parabola. The axis of symmetry is an imaginary line that runs down the middle of the parabola and breaks it into two mirror image halves. The vertex, or the standard form, of a quadratic function is this: f of x equals a times the quantity x minus h squared plus k, where a cannot equal 0, or this will no longer be a parabola. It's important to note the signs in front of h and k. This is going to be very important. We have subtraction in the parentheses and addition outside. The vertex of the parabola will always be located at hk. The axis of symmetry will always be the line x equals h. Now remember, x equals lines are vertical lines, and the axis of symmetry will be vertical. In the top line, I have entered the vertex form for a parabola. And once again, I can use these sliders to manipulate my parabola. Now we said h and k are going to be the coordinates for the vertex. And notice if I move h, it's moving my parabola left to right. Let's put it at 3. And if I move k, it's moving my parabola up and down. Now, the a value, this number out in front of the parentheses, is going to be a constant. It's just going to be a number. When that number is positive, you can see it's controlling how wide or narrow your parabola is. But watch what happens as I cross into the negative numbers. My parabola flips upside down. So when a is positive, it opens up. When a is negative, it opens down. And a cannot be 0, because when a is 0, you no longer have a parabola. In fact, you just have this straight line. If the a value is bigger than 0, that means it's a positive number, and that will make the parabola open up, or teachers usually call it smile. If a is less than 0, meaning it is a negative number, the parabola will open down, which means it will frown. Let's look at a MyMathLab example. This problem says use the vertex and intercepts to sketch the graph of the quadratic function. Give the equation of the parabola's axis of symmetry. Use the graph to determine the domain and the range of the function. Below the line, we have additional instructions. Use the graphing tool to graph the function. You're going to need the vertex and one of the intercepts when drawing the graph. I've begun by writing out the vertex or standard form for a parabola. Down below, I've written the sample problem. Now, one thing to notice, When something is in vertex form, it is solved for y. Y is the only thing on the left side of the equal sign. If you look at the equation I've been given, I don't have y alone. If that's the case, you have one step to do before you're really ready to begin, and that is get y by itself. So the opposite of subtracting 1 from something is to add 1 to it. What you do on the left side of the equal sign, you need to do on the right. Now we have y equals x minus 3 squared plus 1. Now this is in standard vertex form. I can now identify my h value as what's sitting after the subtraction sign, and my k value is outside the parentheses at the end. This tells me my vertex will be located at the point 3, 1. So the next thing that I would normally do is find my intercepts. To do this, you need to know that whenever you have an x-intercept, it has to be a point on the x-axis. For instance, this point here. Any point on this axis will have a y-coordinate of 0. So to find your x-intercepts, you need to set y equal to 0 in your equation. So I take my original equation, substitute 0 for y, simplify on the left, and oh no, I've got a problem here. Because if I'm trying to get x by itself now to find the x-intercept, I need to undo this squaring operation next. And as we've seen before, the inverse of squaring something is to take its square root. I do that on the right, and I do that on the left. The right-hand side, the square and the square root cancel, leaving me with x minus 3. But the right side says the square root of negative 1. Square root of negative 1 is an imaginary number. Remember, if you have a negative number under a square root, you can't find a real value for it. So at this point, my equation is nonsensical. And this is telling me that I will not have any x-intercept for this parabola. Now, if my equation did make sense at this point, so let's change it just for the sake of argument. Well, square root of 4 is 2, and I can finish getting x by itself by adding 3 to both sides. In that example, x would end up being 5, and we would have our first intercept right here at 5. However, again, that was just a hypothetical example. I guess I better go try and find my y-intercept. And there would only be one, because if there was more than one, it wouldn't be a function. Any point on the y-axis, such as this one, for example, this is the point 0, 4. Every point on the axis has an x-coordinate of 0. So I'm going to begin finding my y-intercepts by letting x be 0. Substitute 0 for x, simplify on the right, and then finish by getting my variable, in this case y, alone. So add 1 on both sides. So therefore, I have found that this parabola will have a y-intercept at 10, the point x equals 0, y equals 10. So that will be here. And I haven't graphed my vertex yet, but that would be here. The axis of symmetry is, and you're supposed to type in an equation. The vertex, which is here, is always a point on the axis of symmetry. So therefore, I know my axis of symmetry has to be this vertical line. This is the line x equals 3. It begins with x equals because it's vertical, and it passes through 3 on the x-axis. But also remember, we said the axis of symmetry is always x equals your h value. Remember, here was h, here was k. My h value is 3. Either way, you get the answer x equals 3. That line of symmetry must create two mirror image halves. So if I have this point at 10, 3 units away from the axis of symmetry on the left, I have to have a point corresponding to that 3 units to the right of the axis of symmetry. And now you can certainly begin to see this curved shape taking place. One additional thing I will point out here, notice there's nothing sitting in front of my quantity squared. This is where the a value would normally be. So if it's not there, what is it? Well, just like many other situations, if there's no coefficient, you can always make it a 1. So the a value for this particular parabola is 1, and because it's a positive number, I know it should be opening up. Very quickly, I'll show you how to do this in my math lab. So when I have done all my calculations and I'm ready to graph, I click to get the graphing tool. From the palette, you're going to choose the icon that looks like a parabola. And again, you're going to get these helpful instructions at the top. So you click the graph to plot the vertex first. So I pick a point and it puts down my parabola. Now you can see it's opening up, and I just have to click on another point, and you should be using your intercept. Whatever that y-intercept is, in our example it was 10, you will click a point there. But I like my answer, I hit save, and it shows up here. Going back to our problem, we have a couple of things to answer. The domain of this function is the lowest and highest x values. So when I look left to right, well, there's this point that has an x coordinate of 0, but then there's -1 will be somewhere out here, and -2 will be somewhere out here. Since this parabola does keep going off the edge of this graph, I can't state the lowest x value or the highest. So therefore, my answer will be the interval -infinity to +infinity. Always use round brackets with infinities. Now the range, I definitely do have a lowest y value. This parabola goes as low as the vertex. But then as far as the highest y value goes, because of these arrows, I'm going to find a point with a y coordinate of 12 and 13 and 14 and 15. So it keeps going in that direction. However, I do have a lowest, and you always name your lowest value first when you're doing interval notation. My lowest y value is 1, and I do equal that value because it's the vertex. And then it keeps going, going, going. And that gives you your domain and range. Right, I want to do another example quickly. So I've just made up my own vertex form, and there's a few things we should do right away. We want to remember what the formula looks like for the equation of a parabola, which is this, with the vertex being h and k. In my equation, the first thing that I would observe is my a value. My a value is -2. Because a equals -2, a negative a value causes the parabola to frown. So I know immediately it's going to look something like this. The next thing I always identify is my vertex. Now I warned you, you have to be really careful here. You have to observe your signs. I have a plus where the standard form has a minus. So I have to think very carefully here. I'm going to take this equation, rewrite it. Okay, now h is what comes after the subtraction sign. If you don't have a subtraction sign, well, you need to rewrite it so there is one. Adding 3 is the same as subtracting a -3. We saw this once before, but we were working in the other direction. We took subtracting a negative and changed it to addition. Well, you can do the reverse. You can take addition and change it to subtraction of a negative number. Now I can see my subtraction sign. And therefore, what sits after the subtraction sign is my h. I have a plus sign here. The formula has a plus sign, so those match. Therefore, my k value will just be positive 5. Next up would be to find the intercepts. The x-intercepts, remember, are all on the x-axis, and because of that, they're always going to have a y-coordinate of 0. And one thing I should mention here is notice this original equation is solved for y. So I didn't have to do any steps before I began diving into the features. I'm going to substitute 0 for y, and then I have to solve for the variable x. I'm kind of going to work my way in towards the x. You always get rid of your outside additions and subtractions first. And by outside, I mean it's outside of this grouping symbol. So the opposite of adding 5 is to subtract 5. And I do that on both sides. The next thing you would always move is this coefficient in the front of the parentheses, because I want to get just the parentheses by themselves. So this is -2 times a quantity. Therefore, the opposite operation is division, and I divide by -2, what I want to get rid of. Now, -5 divided by -2 is the same as positive 5/2. I'm left with x plus 3 squared, still going. The inverse operation to get rid of squaring something is to square root it, and I'm left with square root of 5/2 equals x plus 3. Now, square root of 5/2 is going to be a decimal, but it is a real value because 5/2 is positive. Positive numbers under square roots are totally okay. I'd have one more step to go here, which is to subtract 3 to get x alone. X is going to equal square root of 5 over 2, and then take away 3. And this will be a decimal, so at this point you would probably pick up your calculator and type that in, 3, and it's negative, we'll say 1.4. So x, negative 1.4. So I do have an x-intercept this time. Now, right at this step where I introduce the square root, there's an important rule at play here. Whenever you introduce a square root into a problem, you must always consider the positive and the negative root. What do I mean by that? Suppose I had the number 4 and I introduced a square root symbol over it. What number can I square to get 4? Well, I can square 2, so 2 is a square root of 4, but it's also true that I can take -2 and square it and also get 4. In other words, when you introduce the root symbol, you must consider the positive and the negative root. So how does that impact my work? Well, at this stage, I would branch off and form a second equation. So once again, I'm going to take the square root on both sides, but this time I need to consider the negative root. So this would have been my positive root, this is my negative root. And that does change things just a little bit because now you have a minus square root of 5 over 2 equals x plus 3. Okay, remember the square and the square root cancel, and you would finish by subtracting 3 on both sides. This gives me a second x-intercept or root, and I'm going to go back to my calculator and put that one in as well. So now you can see I've gotten a second x-intercept value of approximately, if we round to the nearest tenth, negative 4.6. Fortunately, with y-intercepts, you will only ever have one, if you have one, when you're working with quadratic functions. So all you have to do is let x equals 0, go back to the original equation, and substitute 0 for x. Now in this case, that's very simple. The variable is already by itself, so I use order of operations, or PEMDAS, to simplify the right-hand side. and you get a y-coordinate of -13. And what else might you be asked about? Well, don't forget we've got the axis of symmetry. The axis of symmetry is always a vertical line, so it will always begin with x equals. So whatever the h value or the x-coordinate of the vertex was, that gives me the equation for my axis of symmetry. And very quickly, just to show you what the graph would look like, here is my vertex at -3, 5. Here are my x-intercepts, 1.4 and -4.6. I have to zoom out a little bit to see my y-coordinate at 0, -13.